I bet you didn't know Saturn's rings are made up of billions of particles ranging from tiny grains to massive boulders. Space is vast. It's filled with wonders, beyond our wildest dreams. Among these wonders are planets adorned with rings. These rings are not mere decorations. They are dynamic systems, constantly evolving. They tell stories of cosmic collisions, gravitational dances, and the birth of celestial bodies. In our own solar system, Saturn reigns supreme as the ringed planet. Its elegant rings have captivated astronomers for centuries, but Saturn is not alone. Far beyond our sun, a giant planet named J1407b circles a distant star. This planet boasts a ring system so massive, it dwarfs Saturn's. J1407b has earned the nickname Super Saturn. Its rings are a staggering 200 times wider than Saturn's. Imagine the sight. These rings would dominate our night sky if J1407b were in our solar system. This essay delves into the captivating world of rings. Join me as we compare and contrast the ring systems of Saturn and Super Saturn. Prepare to be amazed by the beauty and chaos of these celestial wonders. Saturn's rings are its most defining feature. They are a breathtaking sight even through a small telescope. These rings are not solid structures. Instead, they are composed of countless particles of ice and rock. These particles range in size from tiny grains to chunks the size of houses. The rings are incredibly thin. Despite their vast width, they are only a few tens of meters thick. Imagine a sheet of paper stretched across a football field. That's how thin Saturn's rings are relative to their width. Saturn's rings are divided into several distinct bands. These bands are separated by gaps where the density of particles is lower. The most famous gap is the Cassini division, named after the astronomer Giovanni Cassini. He first observed this prominent gap in 1675. The icy particles that make up Saturn's rings reflect sunlight beautifully. This gives Saturn its distinctive pale yellow hue. The rings are also responsible for some of the most dazzling displays in the solar system. As Saturn and its rings orbit the Sun, the angle at which we view them changes. Sometimes we see the rings edge on. They appear as a thin, almost invisible line. At other times, the rings are tilted toward us. They become a breathtaking spectacle. The rings interact with Saturn's moons in fascinating ways. Some moons, known as shepherd moons, help to keep the rings' edges sharp. They do this through their gravitational influence. Other moons create gaps in the rings or carve out intricate patterns. Saturn's beauty isn't limited to its rings. Beneath the rings lies a massive gas giant. Its atmosphere is a swirling canvas of storms and clouds. These storms rage for years, even decades. One of Saturn's most striking features is its hexagonal storm. This massive storm is located at Saturn's North Pole. It's a six-sided jet stream larger than Earth. Scientists are still trying to understand the forces that drive this bizarre and persistent storm. Saturn's atmosphere is composed mostly of hydrogen and helium. It also contains traces of other gases such as methane and ammonia. These gases give Saturn its distinctive banded appearance. Each band represents a different layer of the atmosphere. Now, let's journey beyond our solar system to the realm of Super Saturn, J1407b. This distant world orbits a young star about 434 light-years away. It was discovered in 2012 and its sheer scale boggles the mind. J1407b's rings are truly colossal. They span an estimated 180 million kilometers in diameter. That's more than 200 times the width of Saturn's rings. If you could replace Saturn's rings with J1407b's, they would be visible from Earth. They'd appear larger than the full moon. The discovery of J1407b sent ripples of excitement through the astronomical community. It offered a glimpse into the diversity of planetary systems beyond our own. It also raised intriguing questions about the formation and evolution of such massive ring systems. While both Saturn and J1407b possess magnificent ring systems, there are significant differences between the two. These differences provide valuable insights into the processes that shape these celestial wonders. Saturn's rings are primarily composed of ice. This is likely due to their location within our solar system's frost line. This is the distance from the Sun where it's cold enough for volatile compounds like water ice to condense. J1407b's rings, on the other hand, are thought to be composed of dust and rocky material. This suggests that they formed differently or are at a different stage of evolution. Another striking difference is the organization of the rings. Saturn's rings are relatively well defined, they have distinct bands and gaps. J1407b's rings are more chaotic and clumpy. This suggests that they are younger and have not had as much time to settle into a stable configuration. The formation of planetary rings is a complex and fascinating process. Astronomers believe that rings can form in several ways. One possibility is that they are remnants of material left over from the planet's formation. Imagine a cloud of gas and dust swirling around a young star. As the planet forms, it sweeps up material from this cloud. However, some material may be left behind in orbit, forming a ring system. Another possibility is that rings are the result of a cosmic collision. A moon or other celestial object may have ventured too close to the planet, only to be torn apart by its gravity. The shattered fragments would then disperse into a ring. The formation of J1407b's rings remains a mystery. Some scientists believe that they are a relatively recent phenomenon. They may be the result of a recent collision or the disruption of a moon. Others speculate that the rings are in the process of forming planets. The vastness of J1407b's rings and their clumpy structure have led some astronomers to theorize that they might be a hotbed for moon formation. The gaps and clumps within the rings could be gravitational sweet spots where material can coalesce and grow. Over time, these clumps could accrete more material. They could eventually become large enough to form moons. This process is similar to how planets are thought to form in the protoplanetary disks around young stars. If moons are indeed forming within J1407b's rings, it would be a stunning example of planetary system evolution in action. It would provide valuable insights into the processes that shaped our own solar system. Saturn and J1407b, each with their unique ring systems, offer a glimpse into the vastness and beauty of our universe. They remind us that there is still so much to discover out there, beyond the familiar confines of our own solar system. Saturn's rings, with their elegance and intricate structure, inspire awe and wonder. They are a testament to the delicate balance of forces at play in our universe. J1407b's rings, on the other hand, represent the raw power and chaos that can shape planetary systems. Which ring system is more impressive? That's a matter of perspective. Some may find beauty in the order and symmetry of Saturn's rings. Others may be drawn to the sheer scale and dynamism of J1407b's. As we continue to explore the cosmos, we are sure to find even more wondrous and awe-inspiring sights. The universe is full of surprises and it never ceases to amaze. So keep looking up and never stop questioning the wonders that surround us.